In geothermal applications, Turboden designs and builds power plants based on the thermodynamic principle of the Organic Rankine Cycle technology, converting the heat of the geothermal fluid into electricity and heat for various uses. Geothermal energy is a renewable energy source derived from the heat in the deepest layers of the Earth's crust. The use of this energy source is inexhaustible in the long term. It is available 24 hours a day, all year round as a baseload, with no harmful emissions thanks to the total reinjection. Hydrothermal systems consist of permeable rock formations. The water which permeates into them is heated by layers of hot rocks. The hot water is brought to the surface by means of a production well, which intersects with the aquifer at a depth of 5 kilometers. Turboden solutions cover every kind of geothermal resources, from low-temperature water to high-enthalpy steam, with modules from 500 kilowatts to 15 megawatts electrical output. The minimum temperature conveniently exploitable is around 100 degrees centigrade. Hochtief Energy Management, a company specialized in energy projects, subsidiary of the construction group Hochtief, has developed with Turboden 2 geothermal power plants, 5.6 megawatts each. The 2 plants have been commissioned and started up in 2013 to supply electricity to the Bavarian grid. The technical solutions adopted for the Hochtief projects are right at the state of the art, with thermodynamic cycle optimized according to the specific frame conditions. The turbo generator exploits 2 pressure levels by means of 2 turbines coupled to the same generator. The working fluid used is a non-flammable, environmentally friendly refrigerant with excellent thermodynamic properties. The shell and tube heat exchangers have special steel tubes to avoid corrosion issues. The air-cooled condensers are designed with low acoustic emission due to the proximity of inhabited areas. Let's take a closer look at the route followed by the geothermal water within the process. A submersible pump pressurizes the water in the production well to feed the ORC cycle at a temperature of 140 degrees Celsius with a flow rate of 450 cubic meters per hour. The pipelines of the balancer plant carry the geothermal water, after appropriate filtering, to the heat exchanger of the ORC plant. The water passes first inside the tubes of the evaporator, then inside the preheaters, transferring its thermal energy to the working fluid that is contained inside the pressurized shell. The water, cooled by the ORC heat exchangers to a temperature of 50 degrees Celsius, is finally carried back to the aquifer by the injection well. This system thus creates a closed circuit for heat exchange between the geothermal reservoir and the ORC plant, where the entire thermodynamic cycle of the working fluid takes place. The organic working fluid is heated in the preheaters and then vaporized in the evaporator. The organic fluid vapor powers the turbines, which are coupled to the electric generator, producing electricity to the grid. The vapor then passes through the air condenser tube bundles, where it is cooled and condensed by the airflow induced by the fans. The organic fluid liquid condensate is finally collected in the hot well and pumped by the ORC pumps to preheater and evaporator, thus completing the sequence of operations in the closed-loop circuit. The operation of the ORC plant is automatically controlled by a supervision control and data acquisition system which adapts the load to the variable conditions. The SCADA system measures and controls all the relevant variables of the process in order to ensure a safe and optimized operation. Thanks to this system, the plant can be fully operated from remote with no need of continuous attendance. Turboden's specialized staff can connect from remote to monitor all the parameters in real time. Every geothermal energy source is unique. Turboden's power plants are tailor-made and optimized according to specific boundary conditions and requirements. Turboden, pioneer of ORC technology, confirms its standing of supplier specialized in the engineering, procurement and construction of geothermal power plants.
Welcome to another Turboden Talk episode. Today the topic is geothermal energy. Our friend Alexander Richter will give us a brief overview and update of geothermal energy worldwide. I will then give you an introduction of binary technology as an efficient system to generate electricity from geothermal sources.
My name is Alexander Richter. I'm the editor of Think Geoenergy. In this video presentation, I provide you an overview of the global geothermal power market as of today for our friends at Turboden. The global geothermal power capacity stands at around 15,400 megawatt as of year-end 2019. And we have a number of countries that stick out with regards to the capacity that they have installed. Today, the United States still leads the rankings of the global geothermal community, followed by Indonesia, the Philippines and Turkey. Turkey in particular is a newcomer into the game, with having added more than 1,000 megawatts in the last 8 to 10 years. If you look at geothermal development over the last 25 years, 30 years, we see that there's been a steady growth, while not maybe the large growth that we've seen in other renewable energy technologies. But in the last 10 years we see an uptick in development. And if you look at geothermal power development, we see also a certain trend. So if you look at 2015 compared to the numbers for 2019-2020, we see that binary cycle technology has been the predominant technology being supplied to power projects worldwide, representing about 60% of the capacity added from 2015 to 2020. And if you look at the market share of the different power generation technologies in geothermal, we see that binary cycle plants represented around 12% in 2015. In 2020, the percentage of binary cycle technology in the overall mix of power generation technology applied to geothermal projects shows that binary cycles has reached a market share of 23%. And looking at the outlook of geothermal development worldwide, we see that there is an increase in development. And Think Geoenergy expects an increase of about 3,300 megawatts from 2020 to 2025. And what are the key trends? We see a trend towards smaller scale development and lower temperature resource development, essentially suited for binary cycle technology. But we also see new technologies emerging, utilizing oil and gas wells, applying enhanced or engineered geothermal systems, all tailored towards expanding the geothermal power generation sector, heat exchange systems and so on. but we also see an increasing trend in cogeneration of power and heat. And in that context, technologies that utilize lower temperature resources, in the case of binary cycle technologies, will stick out in the years to come.
Did you know that binary was the first technology invented to generate electricity from geothermal energy? Let's go back to Italy, in Tuscany in 1904, when the modern geothermal age started. The first experiment by Gino Riconti was using a piston engine to generate electricity. It was powered by clean steam. The clean steam was vaporized by means of geothermal fluid. This experiment represents the first example of indirect cycle. But how it works as so-called indirect or binary cycle? In binary plants, there is no direct use of geothermal fluid to generate electricity, but a secondary fluid is vaporized by means of heat exchange with geothermal fluid to spin a generator. Differently from the geothermal steam turbines, the binary working fluid is employed within a closed loop. In such a way, the binary turbine is not in contact with the geothermal fluid, which remains enclosed in the heat exchangers, allowing a full reinjection of the fluid with zero emission to the ambient. Let's go back to the history of this exciting technological development. In the 60s, the Polytechnic of Milano has pioneered the modern generation of binary power plant. Mario Gaia, the founder of Turboden, tested many molecules, laying the basis for the implementation of binary technology in many renewable processes and industrial applications. Where it can be applicable, binary technology, geothermal energy, is the heat from the Earth's core. Evidence of such heat is given by volcanoes, hot springs and geysers. This provides us with an abundant and renewable source of energy. Utilization of this energy is possible where geological conditions allow a fluid to transfer the heat to the surface by means of deep wells. Power generation takes place typically in the interval of 100 C to 250 C. Binary technology makes exploitable the full range of temperatures, especially when the geothermal reservoir is dominated by liquid. Also, geothermal steam can be used to feed a binary plant for power generation. Binary can be efficiently employed also for the repowering of existing single flash plants by recovering the heat from the separated liquid before injection. In such way, it is possible to increment the capacity of the original plant by 30 to 40% with no need of additional drillings. Let me now mention the advantages of the state-of-the-art binary technology. High turbine and cycle efficiency, no erosion or corrosion of the turbine blades, simple maintenance and startup procedures, automatic and unattended operation, long life of the components. Thanks to these advantages and flexibility, as of today, about 400 power plants have been delivered by Turboden in 45 different countries worldwide. In essence, what are the benefits of geothermal as an energy source? First of all, it is constantly available all year round. Therefore, geothermal plants are characterized by high availability and high capacity factor, typically in excess of 90%. It is a flexible, reliable, and dispatchable baseload source of energy. It can contribute to the reduction of fossil fuels and foster local development. Finally, it stands among the cheapest technologies from the levelized cost of production point of view, because once the geothermal source is characterized, there is virtually no cost for the fuel. Also, challenges must be considered. Regulatory barriers, such as long permitting and licensing procedures. Financial barriers, because it is highly capital intensive in the initial phase of the project, where the resource must be confirmed and the project feasibility as well. Awareness, because it is much less known as compared to traditional photovoltaic or wind. Social and environmental barriers, typically related to the drilling activities. People ask me often, where do I see more opportunities for the growth of this technology in geothermal application? Binary has proven to be very suitable for the power production close to inhabited areas or rural areas. Also, remote locations such as volcanic islands can host many wellhead plants in the future for domestic production or export to the nearby islands. It's considered that worldwide there are 5 gigawatts of traditional single flash technology installed. This virtually represents 2 gigawatts of additional binary plants that can be added as a brine recovery project, with no need of additional drillings. Also, the new drilling techniques can enable to bring geothermal everywhere, and hopefully oil and gas companies will be more keen on utilizing their assets for geothermal development. These are the main drivers I see for a future growth of this application. Geothermal is also able to provide combined heat and power solutions for heating the building sector and the industry. Geothermal large heat pumps, which is the reverse process of a binary cycle, are now at the forefront of the strategy for decarbonization and electrification of the heat. My mission, Turboden's mission, is to mitigate the global warming by implementing clean and efficient energy systems that are safe, cost-efficient, and easy to use. Geothermal is one of the greatest untapped opportunities we have to clean up our environment for the next generations. Stay tuned for the next talks, and clean energy ahead.